Yeah, very good morning to all present in the session. Hope my voice is audible.
Yes, good morning.
So we can move ahead with the clustering. Yesterday we discussed about the different kind of an algorithms. Then we'll see some deep learning concepts as well. Please just turn off your mic. So this is I'm taking at the k-means clustering. K-means means clustering provides another machine learning. So this is just we can take it. We have to perform some implementations, just like yesterday we saw about and the classification. Similarly, I can share this notebook to all so that you can prefer it for the future purpose as well. Only 5 minutes so that I can share it. So sorry, share it. Anyone with the links, so copy link, done it. So Teams, Teams chats, I just shared it. Let's check it now. Lab.research, you can refer the notebook as well for the future perspective as well. Secondly, I can go ahead with this IDMI data science. Just share it again with this collab in your WhatsApp group. Please refer it. Now the clustering, I'm moving here about this particular thing. It's unsupervised. Yesterday already I defined about the unsupervised version. It's not a label. That's without knowing the labeling data. We have to just go ahead with the clustering or the grouping about that particular predictions. So clustering and k-means clustering. We have to see one algorithm here. So first we have to import some data here. So let's import numpy as np, import pandas as pd. So these two things is done. It you can use the other libraries as well. It might be required to visualization as well. So clustering is a type of unsupervised machine learning algorithms that involves grouping a set of objects in such a way that objects in the same group or group or the clusters are more similar to each other than those in the other groups clusters. And it's a widely used in data mining, pattern recognitions, image analysis, and bioinformatics we are using. Types of clustering, there is hierarchical clusterings, agglomerative, divisive, partnering clusterings. And we are looking for here to understand about the k-means clustering is the most popular algorithms in the category. Uh, we have to see some practical implementations with the k-means clustering algorithms. So I'm moving here to load my data set. So load the data set. So each step I will try to perform it. So load the data set, pd.receive. This is from this respective. I can take it, this data here. So my data set is utilized. Already I shared the notebooks. You can open the notebooks and separate notebooks. You can take it and just perform the practical implementations along with me. So please just take a note and perform the operations along with me. Definitely you will get the idea. And now in my data set, what are the features are there? So in my data sets is the channel, region, fresh, milk, grocery, frozen, detergents. Or if you I will go ahead with this particular, for example, HTTP about this data sets, for example, if I will go ahead, it's a wholesale customer, obviously, control C, control V in a Google will be there. So we can go ahead. So you can see that channel regions, the data set looks like this. So this means it's a data channel is there, region is there, fresh, milk, frozen, and all the things are available here from this data. Uh, so let's we have to perform some practical implementations here. Already I taught about you like how we can deal about the practical implementations whenever we have this 440 rows and 8 columns are there. So we have to first understand about what are the columns are present. What do you mean by this? Channel is what? Like this column represent the type of customers. It's often encoded as an integer where one might represent Horeca or the hotel or the restaurant cafe, and two might represent retail. So there would be things available in the channel 1 and 2. If you want, you can go ahead. Like for example, if I will go ahead DF, that channel, you can see to it, that channel is C is capital or what? C is capital. So better you can copy and paste it. Dot value count, sorry, config value counts. You will get about the idea about that. One is channel having two types, 1 and 2, where one is represented as the hotel or the restaurant or the cafe type, and two is represented as a 142. That's count is given. That's we can call it as the retailer or the retail. About this. Similarly, the region is there. This column indicates the geographic regions where the customers is located. Like the channel column, it's usually included as an integer where each number corresponds to the specific regions. We are not aware about this, so you can just copy and do it about the same thing as the region as well. If you want to do it or check it, what kind of parameters are there or what kind of the regions are available. So you can just do it the simple line of the code value count. So 321 or 312, the three third region is 316. When the region is 1, it's a 77. When the region is 2, it's a 47. So these are the things which is given. Now we can move ahead with the next one is about the fresh. Fresh is something, this column represents the annual spending on the fresh products. Obviously, the data set is of products which like the grocery, this milk, grocery, about the day-to-day life where the groceries we are purchasing like frozen detergent powder, delicacy, milk, fresh. About this all the things is like the vegetables fresh in terms of I can say that vegetables, fruits by the customers measures in monetary units. That should be the milk is there. That's a column represents the annual spending on the milk. As a data scientist or as a data analyst, we should understand first of all the column or the features or the variables. That is a main concern and main important thing. So the grocery is there. This column represents the annual spending on the grocery items. Then the frozen is there. Frozen is already you aware it. The column represents the annual spending on the frozen products, like vegetables is there. Frozen meat should be there by the customers measured in monetary units. Detergent paper is there. Uh, Spending on detergent papers. Then delicacy is there. This column represents the annual spending on delicacy products like the gourmet foods, fine meats, and cheese by the customers measured in monetary units. So the data sets could be used for the customer segmentations. in retail or wholesale settings. For example, clustering algorithms like the K-means can help identify distinct groups of the cluster based on their spending habits, which could inform marketing strategies, inventory managements, and sales. See, this K-means clustering is more utilized in YouTube as well as the Instagram or the social media. The people's interest or the group of the interest will represent it. That's why you always see that hashtag of that concept is going on in the Twitters and the X or the trending, like, because the people are interested to that particular news or that particular informations. So that is the most usable algorithms in the segmentations or the clustering base. So this is a very, very important algorithms, not algorithms, this is the concepts. If you can go ahead and check about the info, so df.info, you can see that info, you will get the idea about that all the data types are the integer data types here. So non-null count and all the things is there. If you can go ahead, check with the shape and all the things, you can go ahead. Now, again, as I told about the MySQL will be the Bible of the machine learning algorithms. So I try to use the sklearns library by Hooper Group. So Google, first of all, make a Google will be your best friend. I always told that make a Google is your best friend. Definitely you can learn anything from this universe. Any certifications, any courses, anything from the Googles. It's the best place, best platforms. You can search anything. Let's, I'm going to search about like the basic one is the k-mean clustering here. I'm looking for the algorithms. So from SQ, first of all, the standard scaler, that's yesterday only I taught it, because this is the data. The data is obviously, I'm not going to understand about it, what exactly it's look like is. So as this particular things, it's totally up to you. This is a channel in the regions. Let's some consider, or my stakeholders will telling me that channel regions does not create any impact. So you can remove it. It's totally up to you. I just need the annual spending on the fresh milk, grocery, frozens. This is a customer's investment or the annual investment on the fresh milk, grocery, frozen, detergent powder, delicatessen. I need it. Only that, like fresh to delicatessen, I need the clustering. So it's your duty that you have to go ahead and perform. So I'm going to do it as the dropping the columns. So how we can do with the dropping the columns? I'm taking the X. X will be my, already you are aware it. That's how I can define it about this particular thing. This is not a label data. So please take a note of that particular things. So I'm taking this X is equal to what will be the commands. Yesterday we saw that df dot, sorry, df is capital. So df dot drop. I'm taking as the two columns here. So obviously the two columns are here is the first is the channel. I can take its channel, copy and paste it better so that no spelling mistake will be happen here. Collab will take a time to provide us, but if you use the Jupyter notebooks from the Anaconda, 100% you will get a very fast tactical implementations. But obviously it's need to install it in your systems. So it will take a time to installations and all the things. So these two things will be going on, and already whenever if you read my pandas notebooks, you find it all the solutions is given in pandas. Whenever or in data frame, whenever we need to drop a columns, we use axis. So axis is also equal to 1 when we drop the columns, and if we drop the rows, we always use axis is equal to 0. So please take a note of that particular. Now when I will do it this particular things, if I will go at X, you can see that my X, so the two columns are going to be dropped from here. Original was the channel and the regions. Now annual, annual about this particular things, spending on this fresh milk, grocery, frozen, detergent, powder, paper, delicatessen is only there. It's not about the region or the channel. So we can go ahead about this, standardize the data. That's the very, very important. Yesterday only we saw about this particular thing, standardize the data. How we can go ahead with the standardize the data, that's already you aware it, you know it, what is the library. So the from sklearn, Pre-processing import standard scalar. Now that standard scalar I'm going to store in the scalar. So scalar, standard scalar. Now I can give the x scaled scalar dot field transform. Now let's see to it that whether it's working or not. So you can just see to it that x scale. You can see to it that x scale. Just a second. How my looks data looks like. So you can see that it's in the form of the array. Earlier, how the data looks like, it's going to be transformed. It's going to be scaled with a proper standard scalar. This is a very, very, and the super most important process in model planning and model deployment as well. Because if your mod data is not properly scaled, your model will not provide you the proper outcomes or the accuracy or the predictions. So the scaling is one of the most major concern here. No, categorical data is, yeah, categorical data obviously, uh, but what exactly you want to do it. So categorical data means what exactly? That will be, that's already categorical. It works with the categorical data. Like the channel was earlier, it might be the categorical. So that is going to be converted in terms of the numbers. Like this, as already I told about explanations I given when I talk about these columns. So this might be the categorical column should be there. It's a customer type data is channel is like one is we can say that Horeca. Horeca means we can call it as a hotel, restaurant, and cafe. And the say, number two is we can say that is a retail. So the data is of two types. So the categorical data is like that. So it's already converted into the one and two. If you want to keep this particular things, you can keep it. That's not any problems. But I just show some dropping concept as well. If you don't need to drop it, don't drop it. You can go ahead and you can perform the task directly, just like how I perform the X scale. You can go ahead and perform it. So obviously, it's a categorical data is there. Region would be there. Might be that there is with three regions would be there. Like we can consider the region of the Mumbai, Delhi, Bangalore. If the three regions are there, for example, I'm considering the region wise. So the one will go for the Mumbai, two will go for the Delhi, three will go for the Bangalore. And according to the region is going to be the categorical data is going to be converted into the numerical data. So whenever we have to perform the machine learning algorithm, uh, to any data sets, your categorical data should be converted into the numerical data. So it is a mandatory, either you convert in the integer, the float, but it should be a numerical forms. So that is one of the most important concepts. So obviously the data set is going to be there. So it's important, like you have to convert it from that particular steps. Hope uh, Shamista Pal, I'm cleared your doubts, what you ask about any queries. So obviously the categorical will convert. So it's obviously it's convert because already I first whenever we take any data sets, we have to understand about what exactly kind of a columns are given, what exactly that column meaning. That's why yesterday only when I talk about the linear regressions, that time also I discuss it about that particular. So this is done it. My data is also scaled it. Uh, Now it's important like we have to go ahead with the sklearn cluster k-means. So you can just write about the k-means about this particular clustering sklearns. Automatically the documentation will comes and you can see that a lot of parameters are given. Class sklearn dot cluster k-means. Every parameters is going to be explained and in it is what auto int. Number of times the k-means algorithm is run with different centroid seeds. The final result is the best output of the n int consecutive. What is the max iterations, maximum number of iterations of the k-means algorithms for a single run? What is tau al? That's plot default, so relative tolerance. So each things will be given in the documentation. I always suggest to all the candidates, all of you, make this sklearns whenever you planning to develop any models or plan to build any models. You should refer this scikit-learns instead of taking any help from any other website. The scikit-learns is the uh, vertebral column of machine learning models. I can say that if scikit-learns you not read and you just try to use about that particular machine learning algorithms, definitely you will not understand the fundamentals behind this. So this is very, very important. You can see that from sklearn.cluster import k-means. Obviously the numpy is required. So you can use it. So we can move ahead and just importing this. So initializing the model, I'm going to initialize the model. Sorry, initialize not importing the model. Importing the model. So this is done it. This is done it here. On the next step is I'm going to initialize the model. Initialize initialize the model. So K means is equal to K means n cluster 2, or you can take n cluster 3 as well. I will tell why we are taking the number of cluster is depend random states if you apply the different algorithms. So obviously the next one is again the train the model. So we can define the df. I'm taking the new name as the cluster. Sorry, cluster is equal to K means fit predict X scale. Fit predict X scale. So this is can because here we not have the dependent and dependent variables. So please take a note of that particular things about this. Otherwise, you will get the confusions like where is our dependent and what we are going. It's going to be predict with the class here. So that's customer segmentations. We can go ahead and we can see to it here about this. So we can go ahead with this one by one. Customers, it's a very easy algorithms. It's not about dependence. What I'm coming to that explanations, as I told, that's it's totally depend. There is algorithms is there on what basis we are going to consider about this clustering. So there is a concept is given that is known as the elbow method is there, as well as I can say that uh, one more method that is we can call it as the still how to is one of the most important method. I can show you about for this particular examples from sklearn.matrix import Silhouette. You can see it there. So I'm going to use Silhouette score. On the basis of the Silhouette score, it's going to be, so I can take it about the is equal to, I'm going taking the empty. So for K in K range, for K in K range, K means n cluster is equal to K random state 42, K means dot fit scale data. K means dot. Let's first of all that's we have to draw this. Then we can come to the next part. Otherwise, we will get problems. So first we have to see the clustering here. This particular is done. So I can go for first Silhouette. Silhouette is very important. Elbow method is also there where the elbow is we can I will explain about this particular thing. Silhouette score is equal to 4 K means K means and cluster is equal to K random state 42. K means dot fit underscore predict. Number one, I can take it. One if greater than one, Silhouette score X K means labels. So Silhouette score, that's why it's taking about this two things. Silhouette underscore score. else routing pen 0. We can take the scale data as well from the scale data as well. Let's we have to try this first. Well, it's working all right. Range is not defined. Okay, range is not defined. Scale out the range is not defined. Range is equal to, for example, I will take as the range 1 to 11. So how to score is equal to source input k-means distance allowed is k range. K-means is equal to k-means n cluster k random state 42 labels. So I can remove those particular things. Is equal to k-means portrait scale data. I can take the scale data here. If k is equal to 1, so the data labels. So I can take as the still out the score. Score is equal to score x scale labels. So out the scores data pen score. Let's find else. So that's total find. Test object element. So this is scale. So I can move it. Just a second. So first one is I can define as L is equal to from here df, that's fresh, the two things here is equal to k range is equal to range 11 for k in k means cluster k can take the random state as well. So bit L. It's already is defined here in the next line. So we can do it in a same line. Inertia and k means inertia. For this, similarly, we can T dot bigger size 10 comma 5 inertia, that's Px. Marker you can take as the inertia is equal to X label, title elbow method, second X label is there. Here elbow methods. X label I can take as a number of that's K is then for of clusters. K inertia PLT dot show. Here, hopefully this will work it. In PLT second variant. So definitely this will work it. Again, uh, this particular things we are getting here. So it's a bending about that's elbow methods. There are a lot of methods are there. We taking about the two the data selections I taken about the fresh and the milk column where it's gone fresh and the milk I taken. We initialize the list. There is a lot of still out method is also there. We can see the still out method. It's the most usable method. We define the initialize the list and the range. So this is the empty list inertia. I define its k range has taken 1 to 11. It's that's clustering range I taken from this particular things. So for k in the k, this for loop we have to use it. K means is equal to k means and cluster is equal to k. So for each value of k in k range, a k means model is fitted to the data L. L we define its sample to their closest cluster center inertia, which is append to the inertia list, plotting the elbow methods. This is about the plotting method. This is only the control structure we define it. What happened? Sorry. Inertia you don't know about. So inertia is the context of the k-means clustering. Refers to the sum of square distance between each data point and its assigned cluster center or the centroid. It measures how tightly the data points are clustered around the centroid. So when using the elbow methods, so we plotted the number of clusters versus inertia. Here we define this is the inertia, this is the number of clusters. Inertia typically decreases because the data points are closer to their centroids. Elbow points is what? The point where the decrease in inertia starts to slow down. This considered is considered we can say that this considered to optimal number of cluster, balancing between having enough clusters to capture the structure of the data. So you can see to it that from which particular things it's going to be uh, locate the elbow. So the elbow point, this is obviously this graph, you can see that's this elbow point of the elbow point is where the curve bend. Now tell me where the curve is bent. Anyone? Where the curve is going to be bending from here. Hope my screen is visible, right? Yes. So the curve is bending. So that's why we can say that we can use number of cluster is equal to 2. If the this will come here and the bending will come here directly, we can say that we have to use the 3 or whatever the it will present about the cluster. So just try to about understand about this on what basis that cluster is equal to 2, 3, what exactly we are using. That's why I'm not seen. I just created 3 or 2, but N cluster is totally depend on this elbow method. There is a still outer method is also there. So we can use that method also to calculate it. I can take or define that method as well, the still outer method, so that you can remember it uh, from sklearn. I just try it. So still outer score equal to the range is required or asking for k in k range n cluster k random set 42 dot fit l. This I can remove it. Fit l labels is equal to k means dot fit predict l. If k is greater than 1, still out is the label array labels. That's totally fine. Else, please go append. See, this will be deleted. PLT dot figure y capital. PLT dot figure fixed size. Fixed size you can check it. K range still out a score. Marker I can take still out a methods. Number of cluster k x label. PLT dot title still out a score for optimal number of clusters. PLT dot x ticks. I can take the x ticks as well. PLT dot x ticks k range. I can take x. Let's hopefully it will work it. Function objects that will append. Still how this go. You can see doing that. Now, still how this score, you can see that again it's going to be 2. So number of clusters, how many clusters you can utilize it about this particular thing. So just remember it, how we can use it. There are a lot of methods are there. It's not about one or two methods where we have to decide about how many cluster is we have to use it. So still how to score. It's there is obviously mathematical formula is that b minus a divided by max of a in max of ab, where a is the average distance between the data points. But how we can understand with the graphical representations. So higher the Silhouette score, a higher average Silhouette score indicates a better definite cluster structure. So this is the higher one. You can see that Silhouette score is there at the left hand side or the on y-axis. So the higher Silhouette score will clearly, as compared to the elbow methods, sometimes the elbow method is difficult to understand it sometime, but the cell outer scale is clearly give us the idea about which how many cluster we can use it, because it's a cell outer score here. So maximum cell outer score is a zero point 0.6 we are getting. So that's why this number of clusters or that number of clusters we have to use. So there is a 2. So we can use about number of 2 clusters in this particular example. So hope everyone might understand about like how many clusters we can go and use. That's why I just stop here and just you can see to it that where it's my part. So here we can use about 2 and just run it. So your model is going to be initialized. Now you can go ahead and just do the practical, finish the practical. It's very easy practicals are there. It's not a difficult task. Uh, so this is done it obviously the practical, but we have to see with the practical implementation as well. So let's we have to write something here. to import matplotlib is cluster. I can define as cluster labels is equal to df cluster dot unique plt dot figure big size. So for label in cluster labels, cluster data is equal to df cluster is equal to label. That's fine. plt dot cluster. Everything will come automatically. plt dot scatter just subset. This is something we are getting. plt dot scatter cluster data. So I can change it from here, or I can take it kept as it is. Let's try it with this one. plt dot x label fresh mail cluster legend. So the legend in the legend title, I can use the title using as the cluster. That's hopefully it will work. It's good. So you can see to it that. So this is a cluster visualizations we are getting fresh and the milks where the cluster zero is or the number of customer segmentation zero is we are getting. So we are getting about you can select any two things. So like fresh and milk where we're taken about the cluster data. If you want to select with the different one like the uh, fresh with the grocery or the milk with the grocery, frozen detergent papers, all these customer segmentations, you will get it according to that particular thing. So each cluster is represented by distinct colors like 0 and 1 and labels is cluster 0 and cluster 1. Purpose helps to identify which color corresponds to which clusters, making the plot easier. And you can use the colors bars as well and colors density. So the scatter plots provide a visual representations of how well the data points are grouped into a cluster based on the features like the fresh and the milk. Similarly, you can change it with the from fresh to the grocery or frozen as well. Like if I will go ahead and change with my this particular things as the uh for example, I will change with the grocery. So grocery with the milk or keep the milk as it is, or I can take as the frozen here. Frozen. So obviously it's going to be changed with this particular things with the data. You can see that's how it looks like. So because X and Y am not changed, so these particular is should also going to be changed. Grocery simply the frozen. So there is a group or the clusters. Two clusters is going to be defined because according to the cell how to we have it's showing that's two clusters. If you can define the three clusters as well, but that would be the not ideal using of the clusters. So there is a two clusters we have to utilize it. So you can see that the grocery and the frozen's here. So just see to it that this is the way you can apply it. See, one thing as already from last first day, I always make out like that you have to use always and learn about the Python. If your Python is strong, then whatever the machine learnings, deep learning, or any algorithm should be there, everything will be it's a cup of tea just like that. Because there is a know about like anything we have to deal. Everything is documented. We have to just write a simple line of the codes and just perform this practical implementation. This is all about the clusterings. You can just take see to it that like what exactly we did about this particular things for this data sets. We applied it. So K-means clustering. it's not about like it's not a label data, so we are not going to see that's whether it belongs to which class or that, because it's not labels, but we can see the number of groups about like this particular things. Then obviously we can come to say that cluster analysis, scatter plot, like the grocery versus frozen, color represents different clusters with the color bar indicating the clusters labels or the group of the customers or the customer segmentations. We can say that between the grocery and the frozen. Similarly, you can take different products between this, like the grocery with the frozen, grocery with the milk, grocery with the delicatessen, and similarly fresh with these others, fresh with the milk with the others, then grocery with the others, frozen with the others, detergent, everything. So you can draw different uh, scatter plots and perform the practical implementations and analysis. So this process helps you understand how to group your data into clusters and access the quality of those clusters using both visuals and the quantitative methods as well. Uh, Still, how to scores we saw that purpose to evaluate the quality of clusterings. Interpretation Silhouette scores close to the suggests that the clusters, like how many clusters you can use for the uh, k-means clusterings. Even the elbow methods is there. Elbow methods is to determine the optimal number of clusters by plotting the inertia against the number of clusters. Interpretations is look for the point where the inertia starts to decrease more slowly. This elbow indicates the ideal number of clusters as well. So obviously each and everything I explain it in this both the methods. I utilize it and k-means clusterings. We did it about this. So clustering algorithms are very simple as compared to the regressions and the uh, classifications. Because why it's simple? Because we are just grouping the data or that's to show about the clusters or that batch or the group. We are to separate the things, and with this still okay on the elbow methods, we can come to the conclusions how many clusters or how many groups we can create it. So this is about all about the k-means clustering. So you can just refer for more future purpose of the k-means clusterings and all the things. Now I'm moving towards the next part of our curriculums that is important as the deep learning point of view. Deep learning is already I explained one thing. So I'm taking one more new notebook here so that I can perform the practical implementations so that you will get the better understanding. So I can take as a one more new notebook here. So just see to it that how we can do it. Deep learning is what? That's already I explained it. It's working with the neural networks. Just see to it that. So deep learning to explain practical implementations we have to see here, the one by one that NN and CNN I will try to show you in this particular interval of time so that you will get the better understanding and a better idea about how the practical implementations are happening. Because at the end of the day, you will have the idea like how the actual models you can create. That's all the models are created here. If you want to save it, that's already I shown you about the methods. You can store it, the model. The model name is your about you can store it where it's model. The model name is for this is the k-means. K-means you have to from SQL and that's k-means. So this is your model name. If you want to save it, you have to use the pickle or the job lib, the two library. With the help of the two library, you can store it. So this is a very easy and try to understand about this is a very easy concept. So we'll see about the computer vision and the CNN and the ANN about these two practical implementations. First, we have to understand about the basic neural networks, how it's working scenario of the basic neural networks, or how it's going to be happening in this particular scenario. So actually, the thing is what or how the neural network is working to mimic the human brains. That is the one statement way we could understand, and we should remember as the deep learning. So deep learning is not like just a one statement. It's about a very huge concept, a huge things as a deep learning, and super most important things. So the deep learning, when I'm come to the deep learning concepts, obviously the word clearly and stated clearly, it's a deep drive. So just like how a human brains, just like there's a visual cortex in your brain. I'm talking as a human brain, how as a human brain is working. Like, for example, when I will see the image of the trees, when I will see the image of the human beings, when I will see the image of the cat, dog, or the different birds, animals, cars. For example, I will see the cars, Tata, Maruti, Hyundai, Volkswagen, or different companies, cars. Whenever I will see, how to observe the things like in Maruti, this is the similarity. In Hyundai, this is the similarity. In Tata, this is the similarity. Or there are some type of the parameters, there are the similarities are, or there's some like a headlight is having the same in Tata Motors, or the Maruti is providing the same kind of a things or same kind of a dashboard to their vehicles. There might be some similarity with it. So as a human beings, whenever you will see any object or any things, in your brains, there is a part called as a visual cortex. If you search it, you will get the idea. So in the visual cortex, the thing is going to be passed from your eyes, the brains, and the brains, there are multiple layers of neurons are there in the visual cortex. That one neurons will say that this is the eye of a cat. One neuron will say that this is a ear of the cat. This is the uh, uh, tail of the cat. This is so automatically the structure is going to be created. Your model or your neurons are going to be trained, and you will come to answer yes, this is a cat suddenly. And similarly, when a cycle is passed from your eyes or the image of the cycle is passed inside the visual cortex, there are multiple layer of neurons are there. Obviously, you will get the PDF of all the learning, whatever I'm explaining. You will get it tomorrow in the day afternoon. A lot of materials you will receive on a WhatsApp. So don't worry about that. But my habit is always I try to explain instead of showing or presenting the PPT, or I want to present, uh, apply the practical implementations. So obviously, we'll see the practical implementation as well here. So don't worry about it. We'll see two practical implementation. Was it ANN? ANN is the artificial neural networks. CNN is a convolution neural network. CNN is for the NLP and the computer visions. ANN is for the artificial for regressions and the I can say that the classification problems as well. So we'll have to see all the things, but we'll see according to that how actually the models are working as well. Yeah, thank you, Harsh Bhatnagar. So I'm coming to that example continuity. Uh, I will show the image as well. See, the internet is there, everything is there, so no need to PPT. I will share the documents. You can refer for your future understanding and future purpose as well. That's not a worry. But let's try to conclude about these examples. When you pass image of the cars in your visual vortex, the neurons will might be there are millions of neurons. I'm not say that's one, two, three. Consider 10 neurons are there. That's the best better way you can understand it. So there are 10 neurons are there. So the first neuron will say that's it's a car. Second neuron will say it's a Tata or the Tata Motors cars. Third neuron will say it's a SU. Fourth neuron say will it's a hatchback. Fifth neuron will observe it and say that yes, it's a hatchback. It's not a SU. So there are multiple things will come suddenly in the minds, and at the end you will coming to the decisions. Yes, it's a Tata Motors cars and it's a hatchback or this whatever the things. Similarly, cycle, motorcycle, or that particular things. When you see suddenly in the night of the cars, logo, name, everything is not observable. But there are conditions already. Your visual vortex or the brain is trained. How the Tata Motors headlights looks like when you pass a vehicle, how the wheel cap, how the window, or how the back design, how the front designs, whether it's a facelift or not. All your brain is already trained on that kind of features. In the night, when the vehicle is passed, your observation might be true. But how it's possible? Because your model is trained. Your brain is trained on that particular features. In the word visual cortex, the thing is passed. Just like your child, if you have a child, obviously The first stage of the child's, he not understand anything. We always make him and saying that he's your papa, I'm a mom, I'm a dad, continuously. So when the feature is passed, his brain is trained. So he always remember that, yes, he is my dad, he is my mom, she is my mom, he is a car, he is a bike, because his neurons is trained. No need to train again and again. So that is the difference of the machine learnings and the deep learning. Deep learning is something once the model is trained, it will works like a human being. So no need to go ahead again the feature extractions, feature engineerings. Only you have to pass the image. Just like if you remember it or not, I don't know. When I pass the new data, regressions or the classifications, I have to always do the scaling, feature scaling. If you remember it, standard scaler. Yesterday only we saw that. But when I perform with the deep learnings or deep learning or advanced machine learning algorithms, once my model is trained, I have to just pass the image. No need to go ahead and apply again the uh, number of filters and everything to understand what the image. Your model is trained just like a human beings, and you will get that kind of an output. If your model's accuracy is perfect, you will get the perfect results. If your model accuracy is bad, obviously some images he will understand, some images he will not understand. So that is the scenario. It's about the deep learning. So deep learning is like to mimic the human brain. Behind the, to mimic the human brains, how human brains are working. I just explained that scenario. Now, how your model is going to be understand. There are three stages in this particular things. The first stage, I can say to it that the first stage is I'm coming to is here about this particular things about the fully connected layer, CNN. I'm not taking any websites, just taking this simple image and try to explain you people. Please try to get it. See to it that. So flatten layer, fully connected layers, softmax layers. So let's I have to delete this because this is not a perfect one. I can go ahead again and take the next example here because this is not example of this fully connected layer ANN. That's the most important part. We have to see to it that you can take this, copy paste it. Yeah, your neural networks look like this. Please try to understand the explanations. The first is your input layer. The second layers are called as the hidden layers. The third is again, there may be the multiple hidden layers. You can take it. It's not about one, two, three, four. Only few layers are there. There might be a multiple hidden layers would be there, and only one output layers. So like there might be any kind of a data. Why deep learning is so important? Why deep learning is having the advantage over to the machine learning? Why? Because deep learning is the model or deep learning is the algorithms who are capable to handle the structured, unstructured image, video, text, audio, any kind of a data would be there. Deep learning say, yes, I'm capable. I can handle it. But machine learning having the certain range, certain disadvantage. Deep learning, machine learning is only capable to take the structured data. Your data should be in a proper format, just like the row and the columns we saw in the regressions, we saw in the uh, classification. So try to understand why deep learning is more uh, weightage as compared to the machine learning. This is the first time telling the basic. Deep learning is capable to take any kind of a data because it's treated as like a human being. The image translations, human, that's generative AI. These all are the part of the deep learning. Those who are planning to transit his career from the Gen AI, those who are planning to learn the generative AI, they should learn the deep learnings in depth. Then they will understand the Gen AI, how the Gen AI is working, how Chat GPT, how the Llama 3, how the LLM models, how the Google Gemini, how the Cloudy 3 or the BERT. These are different models, Croaks are working. Because of OpenAI Sora is fascinating, is coming very hard. That's you have to just write a line of a codes and the audio video will be created automatic or now there is models, but whatever the open AI is there, there is no comparison with the open AI. So there is a lot of models will become in futures, but all are working just like how human being is thinking. Once GPT-3 is trained on 175 billion features, so now you can understand it. We are just train a model that linear regression only having the 13 features. You should think it GPT-3, not talking about GPT-4 or GPT-5 or GPT-4 Turbo. I'm talking about GPT-3 is trained on 175 billion parameters or billion features. Now try to understand it. How many parameters is trained? How model looks like? That's why you are getting whatever you type, you will get the answer. So obviously, language, image translations, language recognitions, uh, sentiment analysis, this all are depends on this neural networks. So the neural networks is completely the three parts: input, hidden, and the outputs. In the input, hidden, there would be the multiple things. There is a bias. Whenever there is any operations are going to be performed, some kind of a bias will be automatically created. Just like if you remember, if y equal to mx plus c is treated as a constant, if you remember it. So similarly, the bias will be there. One more thing is that whatever the operation is there, the input layer is there, the three feature units, input values. When you pass the input values, it's come as an input layer. The input layer will come is in the your neurons, like your visual cortex in the brain. That's your hidden layers, and the output layers, that's your decisions. This is just like how human beings are working, how human beings are thinking. Similarly, your deep learning models is there. Obviously, these operations perform some kind of functions required. That functions are called as activation functions. That activation functions work is to do the process fast. There are a lot of activation functions are there. ReLU activation function is there, preLU function is there, sigmoid functions are there, leaky ReLU is there, tan H, tan hyperbolic activation functions are there. Lot of activation functions are there to perform this task. The main agenda of this activation functions, once the activation function is there, we saw one things in linear regressions, that is MAE, mean absolute error. If you remember it or not, yesterday we finished the topic. Mean absolute error, mean absolute. When you minimize the mean absolute error, your model accuracy is there. So obviously that mean absolute error we called as the loss function. In deep learning, mean absolute error or the mean squared error, that all the functions are called as the loss functions. So the deep learning is the combination of the input, hidden, and the output layers. To perform these tasks or the operations in input to output layers, we need the activation functions. Activation function is required to perform the to create a linearity in the models, so that the process will be fast and you will get the appropriate output. What is the agenda to get the better predictions? Our main agenda is to minimize the loss function. What is the loss functions? There are a lot of loss functions are there. There is just like a mean absolute error, mean squared error, root mean squared error. There are lots of loss function where binary cross entropy is there. Lot of loss functions we can utilize it here. Loss functions work is what? Why we are using the loss functions? Loss function is that to reduce the error between the actual and the predicted. When the loss function will be less or the minimal, your accuracy is increases. That is the main working scenario is there. Now the thing is what actually how this particular thing is going to be happening. So I'm just taking one more diagram here. That's forward propagations. Forward propagations. You can just see to it. This is all the things are the mathematical things. You just need to understand about the concept first. Once you understand about the concept, definitely you will understand everything. Just a second. This is a forward propagations, input layer, hidden layer, output layers. Suppose any documents, any data is going to be passed, is going to be passed this way. If the activation function is minimal at this point, then there will be a no backward propagations. Once why backward propagation is happening, I'm coming to this particular things, how this particular operation is working. Back propagations, backward propagations. Take any image and try to understand it. Otherwise, people might thinking about like, I can take this image. This will be better image. I can get it. So both the things is going to be covered here. In text, I can import it. So this will be the better image. Now you can see that. When you pass any data to your models or the neural networks, when I'm talking neural networks, type A, any type of, there are three most important algorithms: ANN, RNN, CNN. ANN, RNN, CNN, or ANN, CNN, RNN. ANN stand for the artificial neural networks. CNN stand for the convolution neural networks. And the last one, RNN, stand for the relational neural networks. So just remember it about this particular forward propagations, backward propagations. You have to use the input layers. You have to use the hidden layers. You have to use the output layers as well. So forward propagations and the backward propagation is going to be happens once you pass any data. Obviously, activation function involves, the loss function will involve here. If the loss functions is minimal, there will be no backward propagation is going to be. If there is a scope of improvement in the improvement to minimize the loss functions, the backward propagation is again happening. Again, this particular, the data is going for from further, that's input layers, hidden layers, and output layers. Continuously, this process will going on. Till what time? Till the time, like for example, you take the readings. First readings, you'll getting, for example, you calculating anything. First reading, you are getting temperature, for example. Temperature you are calculating of the hot water or the boiling point of waters or the cooling point of waters continuously at certain of time of certain range of times, the temperature will be constant. So till the time of that loss function is not constant, the forward backward will continuously going on. Once you will get a constant loss functions, or the your loss function is not going to be further decreases, the backward propagation is stopped and you will get your output, or your model is going to be trained and you are getting about this particular thing. So this is about the forward and backward. So try to understand. If someone will ask like what is the forward propagations, backward propagations, obviously forward propagation is the first step, like when you pass any data to your neural networks, you will get the output, or your model is start training. The main agenda of when you will say that my model is trained, when your loss function is at minimal point or minimum level. So till what time the process is continue? Till what time the process is continue? Till the time there is a scope of improvement in loss functions. What is the scope of improvement to in loss functions? To more minimize the loss function value. Once the loss function will come as a constant, or when there is a slight changes, very minute changes, automatically your model stop training and you will get the output as well. So this is forward and backward propagation working. This is actual working scenario of your neural networks, whether you use about the any kind of a networks or any kind of a neural networks. Now, ANN is what? ANN is artificial neural networks. CNN is convolutional neural networks. RNN is recurrent neural networks. ANN is the neural network who are dealing with the regression and the classification kind of a problems. Regression and the classification kind of a problem. CNN is only dealing with the image processing and the video processing data. CNN is dealing with the image processing and the video processing data. Recurrent neural network is dealing with the your textual data. You have the time series data. For that kind of a data, your RNN model is capable to provide you the outcomes or provide you the predictions. So that is the main difference between the three models. Like, will come to that epochs and all the things. Please, when we perform about the practical implementations, you will get the idea about that particular how exactly it's working about that. So NN is specially designed for the your regressions and the classification problems. When we have the data of the regression and the classifications, CNN is specially designed for image processing and the video processing. Like when you pass any image, your model is capable to understand and provide you its image of horse or dog. When we pass the data of like the sequential data like the weather forecasting, stock analysis, there is might be any kind of a data, the continuous data would be there as well. Or the NLP or the textual data would be there. Obviously, recurrent neural networks will come in a picture. So why deep learning is important? Because when you plan to understand about the generative AI, recurrent will play a very, very important role at that place. Anyway, we have to start about this particular things, or we have to see some practical implementations on the ANN. I'm trying to elaborate with the first one is the ANN. So artificial neural networks, ANN. How we can go ahead and perform this particular? No, no. And that's already I told, that's ANN and RNN difference already I told it. When we have the textual data, RNN model is there. When we have the classification and regression problems data, then ANN is capable to provide you the results or provide you the predictions. So how can the ANN and RNN be similar? Not at all. RNN is a recurrent, just like you have the you are getting the automated email writer. Automated email writer is just like when you someone is providing the uh, like the, for example, I can give the best example is someone is asking like to tomorrow there is a meeting. If someone is asking on a mail, automatically when you start typing, automatically yes at 4:30 p.m. So that is the example of the RNN I can suggest. Automated. It's a recurrent. The sequence will be there, recurrent. That's previous data is again going to be utilized here. Time series by default would be there. Time series data would be there, because that's why I given the example about the weather forecasting. When we talk about the weather forecasting, time series will play a very important. When we talk about the stocks analysis, time series data will play a very, very important role there. So RNN is we can go ahead with the time series, and linear regressions not, it's about the regressions. That's continuous data, or that particular, when we talk about the classification data would be there, or classification. When I'm talking of problems, it is about the data types. Then ANN will be there, and CNN is obviously have the differences between this. So let's we have to plan to see about the ANN. Let's we have to see to it that some data set here so that we can perform the task. NN, CNN, RNN, all the things should be there. So first, that's basic practical implementations. Already you saw it. So I'm going to take one data here. That's already I will share you. I will share you. Not already I shared it. Mm, This my data is artificial neural networks. Artificial neural networks. So I can paste in your WhatsApp group as well. So you can refer it for future purpose as well. So the data is there. Let's we have to perform the RNN. So first import numpy as port, numpy as np, import pandas as pd, import matplotlib dot pyplot, plt import tensorflow as tensorflow later on. I will come to it because tensorflow is a library we have to use it. So that's fine. And we imported it. So let's we have to run it. Df is equal to pd dot read underscore churn modeling, but I'm not using the churn modeling data sets here. I can use this data sets which I uploaded here. I can copy this path. I can paste here. This is the same scenario we have to use it. So the data set is there. You can see that df dot head dot head exited or not. So your target will be is exited or not about this. The credit score and everything is going to be the UN about this. You can see the textual data is there. So first of all, we have to import the TensorFlow because TensorFlow will come as a library. We have to use it. So import TensorFlow as TF. So importing TensorFlow as a TF, it's going to be imported here. You can check the version of the TensorFlow as well if required. It's cf dot version. It's 2.17. Depend. It's updated every times when imported. Lot of things we have to do it in this practical implementations. Please make us sure about this is one of the best practical I'm taking here. So from sklearn model selection, not model selection from sklearn. Sklearn is always there. Compose, I will explain why I'm using this. Compose import column transformer, sklearn preprocessing, import one hot encoders, import sklearn import label encoders. But I can delete these two things from sklearn models import. No. Sklearn learn dot preprocessing import label encoder from sklearn dot model selection import trend test split rest import trend test split. Then next is from sklearn, standard scalar. From sklearn, confusion matrix, accuracy score, precision, recall. That's fine. It import confusion matrix, accuracy score. And one more thing is I can get it's a classification reports. Let's try to importing this. This all the libraries I will come to explain about one by one. Well, let's see how to check it, whether how the data looks like. So df dot is null dot sum. This is the basic things we have to use it. So all the things are proper because it's a taking from the documentations. Df dot info, we can take it. So informations we can take it's about this informations, what type of a data. As someone asked in the morning about like if the categorical data would be there, then what? So let's we have to discuss about this categorical data. Uh, Here you can see that in the row numbers or the surname is the categorical. Customer ID is there. That's credit score, geography. So I think that's customer ID and this particular things does not have any values. So what exactly I'm going to do here? DF is equal to, or I'm taking I'm writing the comments, taking all rows and all columns in data except that last one. But as per observation, customer, this is a data sets of the, you can see that try to understand about the case study data sets of the credit score, about the loan exited or not, about the estimated salary, whether the person will get the loan or not, that particular things in that. So surname, customer ID, geography, gender, age, tenure, balance, number of product, has cards, is active members, estimated, exited, and all the things will be given. So, but as per observation, customer ID, I can go ahead with this particular thing. As per customer IDs, means first two columns, I'm not required it. Customer IDs and surname not important. So we should drop it. We should drop it. Now capital X is equal to df dot ilock. So three, all the rows, all rows I need it. I'm going to create a dividing about the dependent independent. So dependent is my exited. Please take a note of that. And rest of the will come for the independent. But still the first and second columns, this particular things will be not important. You can see to it that. Even the row number is also not required. The row number columns, customer IDs, surnames, this three. Now, so 0, 1, 2. The starting I'm going taking from the credit score. So from this column, I'm selecting till the estimated salary, not exited. Because why? Can anyone get the loan on the basis of the surname? No. Can the person get a loan on the row number on the no? So these three columns will not create an impact on the prediction basis. On the prediction basis, please take a note of that. Whether the person will get the loan or not, or exited or not, about that particular things. So for this, we are selecting the columns 3 to -1, means start from the columns third till the last, but except the last one, because -1 we define dot values. I just define the values here. This will I can take it later on, and print. I can write about one things, independent variables are comma x. Let's we have to see to it that. So independent variables are what? Your x independent variables are 619, just like you can see that 619 France female. From here it's going to be considered, huh? 619 France female 42 to 0.0 till here estimated salary. Similarly, I'm going to perform here about the practical implementations for the y is equal to df dot ilog. So this is again going to be done. Dependent variables are exited. So these dependent variables are the 101 because the data is already given 101 about this. So this year already this procedure we did it in the past as well while performing about it. Now I imported a lot of libraries here. Column transformer, one hot encoder, label encoder, standard scaler, that's you are with. Why it's required. Let's one by one we can go. First, I'm going to see my data set here, the gender. The first column in my mind coming as the gender. Even the gender is also not going to be affected. Huh? You can drop it if required. But let's at least some things I want to show you about from categorical to the numericals. So female and the male, obviously, two things would be there. So what exactly we can use here, transforming the gender variable, labels are chosen, why we use the label encoders. So we have to use about the label so that you will get the understanding. Transforming gender variable labels are chosen randomly. So I'm defining LE is equal to label encoder. I'm taking from X. Now just try to understand my column. How many columns we have? See, earlier it was the columns was the from row number. Now its column started from credit score to in X. I'm talking estimated salary. The column start from 0, 1, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 0 to 9 you have. Now I'm totally focused on the gender column. Please take a note of that. So that's why I define X in the X. That's why X is totally defined is here. In the X, this is the 0, this is first, this is second, because this is a geography, this is a gender column. So I'm enter here. So 0, all the rows required, but only columns, second columns you have to go ahead. LE means label encoders. Dot fit underscore transform whatever the conditions we given which columns and print X. Now what happened when I will do it here? Now it's you can see that your data could be kept as it is 619 France. Now your gender male female is going to be transformed into 0 and the 1 basis about that particular things. So this line of a steps, please try to understand about this line of a step, how we can go ahead and performing about this particular step, because it's very, very important step. People are not understanding why we are using. So label encoder is a utility from sklearn that is used to convert categorical labels into the numerical format. This is useful for the machine learning as well as the deep learning algorithms. Like here we define about X, about this particular transform. So refers to the third columns in your data sets because indexing always start from 0. So 0, 1, and 2. So it's saying that you have to refers to the third columns in your data sets, which in this case is assumes to be the column containing gender informations. So left it, you given the name, label encoder name is given the short form name as the LE. So lay.fit transform X2 encodes the categorical gender labels into the numerical formats. So this is very, very important. You should understand it. Like the male will be considered as the 1 and the female will be considered as the 0 here about this. So like example we taken as the male and the female. So you can see that the first value already you have the first value is the female. So we are getting a 0 here. But the male, whenever there is a male, you can see that Germany is might be having the female, you can see that male. So at that place, it's automatically come as a 1. So just try to understand this is a very, very important one where one hot encoding as well, because already I defined it about that particular one hot encoder as well. So one by step, first try to understand about this particular step. So we can move ahead with the next one, uh, perform it, because there are a lot of categorical columns are available in your data frame or in your data sets, because the geography is there. In the geography, we can see that France, Spain, Germany, a lot of multiple categorical data is there. So we can use the different way or the. So we have to perform the next one. Hope everyone might understand about this, how we can do it. So I'm using the transformer, the geography columns. Why transformer or transforming the geography? Because there is more than two categorical data is there. Geography, column, variable. So labels are chosen randomly. So CT is equal to, already you define the library column transformer. You can see that. So transformer, we are using encoder, and obviously we use the one hot encoders. So the one is defining, remainder is pass through. I will come to explaining about this particular things. So in the X, we are applying np dot array, the ct dot fit underscore transform X about this particular things. So let's try to understand about this explanation as well. Just a second. What is my X? This was my X, right? So first you can see that this geography column, the France, Spain, France, Germany. So what exactly we are going to perform here? So we are using the column transform. Already I enable about this column transformer and one hot encoder. With the only one hot encoder, we cannot use it. We have to take the support from the column transformer. So both the things will combine together. Label encoder, we use it for where there is a two categorical data is there. Uh, we are using column transform along with the one hot encoder to transform the geography column in your data sets. One by one, column transformer, we enabled it. One hot encoder, we enabled it. We define is CT is equal to column transformer. So transformer is means a list of transformations to apply to different columns. We use the encoder here. You can see that a name for this transformation step. Then we use one hot encoders, the transformation to apply, which will one hot encode the specified columns. So I define is here one, if you can see that, because my column wise, if I can say that credit score column is my zeroth column. So France column would be my first, or the geography columns will be my first column. So that's why I define here specified columns here one in the index of the column to transform. In our case, it is the second column. So that's why it's written as a once. Whenever in Python or any programming language you're performing here in machine learning, you should always remember in pandas, indexing start from 0. Otherwise, people are getting confusions. Then the one is my second column. So I define it. Then remainder is pass through. What it means? It's indicating that columns not specified in the transformers argument should be passed through unchanged. They are not going to change about this particular. And then we define about the X is equal to np dot array. CT means your column transformer dot fit transform to your X. So applies the transformations to the data set. Your data set is your capital X or independent, and converts the results to a numpy array. And np.array ensure that result is in the numpy array. Now we have the data sets. Before the transformations, we have the data like France, Spain, not this, or you can, this is the same thing. So before the transformations, we have this France, Spain, France, Germany, this kind of a data. After the one hot encodings, what will be your data? We have to see it together. After the one hot encodings, what you are getting. So France might be encoded because randomly it's going to be taken as a randomly. Please take a note that. So France might be encoded as 100, Spain might be encoded as 001, Germany might be encoded as 001 as it is. So France might be encoded as the 100, Spain might be encoded as 010, and Germany might be encoded as the 001. Now, earlier, if you go ahead and calculated the columns like 1, 2, 3, 4, 5, 6, 7, the same column are there. Similarly, like the 1, 2, 3, 4, 5, 6, 7 has cards and all the things. So obviously estimated it's already a lot of, so obviously it's not taking all the columns here. But if you can see to it that this is a 1.0, you can just try to understand about this particular scenario carefully about this output, what actually you are getting, like the after applying the one hot encoders to this particular data frame or the data sets. If you have to take in the small data sets and try to understand it, earlier your data should be like this: 619 France female, and later you will get like a data 619100. Like for example, the data I can copy and paste it about this one example way so that you will get it. I'm taking this as the, taking this particular as a comment I can give it. Yeah. How data work, it's one hot encoders or this particular things, please try to understand it. This is a very, very important step. This is yours considered an original data frame. But after encoding, how it looks like, it looks like this. Like it's the data would be going to be transformed and it looks like this. Giving this as a comments, otherwise it will, when I will run it, it will treat it as the error. The data will be looks like is this particular. For example, 619, the France would be 100. The Spain will be looks like 608010. And 502 would be 100, because again the France will come. If the Germany is be there, it might be 001. So the data will becomes, or the one hot encoding. How do we know what is the code for which categorical data? That's already I clear about this particular things. Like this is the, like the zero, and this particular things is for the gender columns. This is for the France columns about this particular things we are applying here. Here it about this. That's for that example I just given to present in the manually about it. You have to do, you have to take a small data sets, like take the data of these. For example, you can take a data things and perform this label encoders and perform this task, then definitely you will get it. But there is obviously you have this particular things. For example, if you can go ahead and just take a data, I can copy it. So I think I have in my one notebook, the data is there. So the data is equal to, I can take it. Already did what with one batch here. So let's try to search it. If it is there, I can show you directly. Yeah, so I got it. So this you can see that print categorical columns are the gender and the country. The country and all the things is there. So I can take it. Sklearn and all the things is there. So we can apply directly. LE is equal to label encoder is there. So for the gender, I'm going to apply here. Just a second. I did a mistake and my data will be, so here instead of the df underscore one, I can give it. So that will be a better one. Df underscore one is equal to PD. Otherwise, my original data is going to be affected. Then just like age, gender, and the, so age is obviously, so we can take about this particular things. We can take its df1, df1, that's gender. That's first you apply this is equal to le. That's fit transform df gender. Now you can see the print about this particular things. So you can see that gender is going to be converted. Earlier, what is your gender? Having the female, male, female. So with, this is a label encoder. Similarly, if you can go ahead, see the data is very huge and we have to perform multiple operations together. And if I can go ahead with this particular thing separately, obviously it will take a huge time to understand about this particular and composites. Now, obviously the import column transformer is already defined. It's so CT, I can define it. The country column, I can take it, or I can copy and paste this particular code it here, CT, or I can give the CT1 here. CT1 is here. So this is for the your CT underscore one. Column transformer encoder, one hot encoder, but here it's obviously we are taking the country. Column transformer, country V1, any name you can give it. Column transformer, remainder is the pass through. So done it. Remainder is this is for your understanding purpose. I'm taking the example. This is not for your data sets. So TFS and P.array constant user you have painted EF1. Yes, that's totally fine. Well, I will get it. You can see to it that. Now, how this particular thing is going to be done it. This is obviously you can understand it. This is for the gender. Now, country. When I'm talking about the country, you can see that France will be 100. The Spain would be, you can see the 100, then 100,010. About this kind of a data, it's randomly it will taking. This first three, you can just see to it that. Don't look about this 25 to 0, about this two last second and last column, and try to understand about this particular example so that you will get the exact idea about how it's going to be imported here as well. So it will come in the first front. That's why I given the example here about this particular as well, so that you will get the understanding. So 100, this first, that's country will come, or that particular geography columns will come front here. You can see to it that 100,001, 100,010,100. It's taking a randomly for France. Whenever there is a France, it's considered as a 100. So if the place of the France, you can see that the Germany place is that's 010, and the Spain place is the 001. So it's taking a randomly about that, and that will be the fixed. Whenever there is a France, it will taking automatically. So it's, I think you ask about how we can understand about the manually, for which categorical data is to be done manually, right? Sharmista Pal, hope your doubt is clear. I just taken one simple data set or small data sets. Just a second. Yeah, so this is done it. Hope everyone understand it. I just taken this is not a part of your what I can say that uh, data set. It's just for understanding purpose. I taken it. Let's we can move ahead with the next step. This whole part says for the example, not your part. This is just I taken a randomly data. Let's we have to complete the practical so that we can at least see about the CNN as well. So that would be our targeted because we have one more hours, 2:30 max to max 2:30. I will take it. So already I told that the syllabus which IDMI provided, it will take about near about to each day is 3 hours. And unfortunately, they are providing me only 2 hours, but I have to take the extra and complete it. So Now the thing is done it. Now I'm moving towards now. Hope everyone might understand why we use about the label encoder, why we use about one hot encoders, why the column transformer is required. Everyone might get the idea. Label encoder is using when we have the only two categorical data, but when we have more than two categorical data, we need to the one hot encoders and the, not one hot encoder alone. Along with the one autoencoder, we require the column transformer as well, so that it will take 100, then 010 or 001, that kind of labeling. If the 4 will be there, then 1000. That's just like a matrix. 1000, 00100, or 0010 and 0001. That kind of output you will get it. So that's why that's one hot encoder is important. In the morning, you ask about the questions if a categorical data. Now your data is already converted in all the form of the numericals. So I'm going for the splitting the data. So splitting the data into train and test. So X train, X test, I taken here about random state. It's totally up to your choice. Test size I taken is the 0.2 and all the things. Also, I can write something here, print X train shape dot shape, comma, X test shape. Similarly, Y train shape, comma, Y test dot shape. So you can see that a shape is there. 10,000 data is there. 10,000 row. So 8,000 in 2000s. Deep learning always require the huge data. Obviously, the next one of the most important is the data scaling. Data scaling is very, very important. So normalizing of the features. So SC is equal to standard scalar. That's you aware it. X train is equal to sc dot fit transform. That's the basic command. That's already we did it in that particular. So your data is going to be trained. If you check it with data, so now building the model. Now this is from here onwards, it's going to be difference building the model. So how we can go ahead building the models. So I'm going to define ANN. ANN means TF. TF is my tensor flow with the keras, tensor flow dot keras dot models is the sequential model. That's already I told that's in the sequential, that is the input layers, hidden layers, and the output layers are there. So this is I define it. Module TensorFlow has no attribute keras. But it's not going to be TensorFlow. Keras, why it's not being module TensorFlow? Let's have to import it first. Whether I import it or not, let's. So from TensorFlow, import keras. Keras from some import layer from layers. Also, I can import the layers as well. Yeah, now hopefully it will work it. So building the model is important. Oh, principal no attribute keras bytes, but yeah, I think I did a mistake. Yeah, thank you for informing keras. Done it. Thank you for your observations. So I just imported the sequential model here. Now adding. Now layer C, how to adding fully connected input layers to the sequential model. So ANN, your model name is ANN. So ANN dot add TF dot keras layers dense. How many neurons you are taking? 6. It's totally up to you. Activation function, I told that's to perform the process, you require the activation functions. To see to it that activation ReLU, this has done it. So the input, I define it because here we have to define that's how many neurons are equal 1, 2, 3, 4, 5, 6. So it's totally up to where like 6, 8, 12, 24. It's not having the restrictions. You can do it according to your, the maximum neurons would be there, the better predictions you will get it. So we have to see to it that one more things about adding. I'm doing separately here, connected. Otherwise, I can write in one uh, share cell as well and perform it. Please explain tensor flow. Let's have to complete the code, then I will come to explanations of the tensor flow. Don't worry about it. I will explain once or twice. Don't worry about that. Uh, let's have to write this first file. The fully connected second layer. To the second layer means what? Hidden layer. Please take it. Instead of second layer, I can write it as the hidden layer so that you will remember it. Hidden layer. The model or sequential model. Model. So your model name is ann dot add TensorFlow dense. Again, I'm using 6, so you can add it. Suppose you're taking as the 12. It's totally fine. You can take it according to your choice. Then I coming to hear about this adding fully connected. Why I'm writing fully connected? Because it's said connected together. That's why I emphasize this word output layers. Output layer. So ann dot add tf dot keras units activations. Here I'm using the sigmoid. Now this is your using term work as a sigmoid as the different functions I use. There are a lot of activation sigmoid, ReLU, leaky ReLU, anything units one. You can take to output as well. It's not a problems. But maximum we are taking for the image classifications and all the things you are using. If you take the two, that's totally fine. So it's not a mandatory. So this has done it. Yes. Now you ask about to import to explain me about one things like to explain you about like the TensorFlow utility. So TensorFlow is a popular for the open source framework developed by the Google. First of all, for the machine learning and the deep learning tasks. A lot of tools for building and deploying machine learning models. Utilities point of view, if I can say TensorFlow core. So Tensor, the fundamental data structure in a TensorFlow, similar to just like a NumPy array. You can create a tensor as well, just like similarly we are creating with the about the NumPys. Then the Keras API is there, TensorFlow core and the Keras API. So high level APIs like the tf.keras, whenever we have to utilize as a high level API for building and training neural networks, simplifies the creations of models, layers, and the training process. We have to use the sequential models like linear stack of layers. It's a straightforward to use for creating a simple models. Then functional API, more flexible than the sequential API, allowing the creations of a complex model such as a multi-input output models, shared layers. Model training is there. A lot of operations we can perform in the TensorFlow, like model training. We are just going to move it to next one. This whatever the things we are applying is the utility of the TensorFlow. Like we are going for to the next one is the model compile. Uh, then the TensorFlow data API. That's slices and all the TF data. Model deployment also we can use to save the models, and we can use the tf.keras with the model name or the path. Then the TensorFlow hub is there, TensorFlow Lite is there, TensorFlow board is there. So like visualization tools. So Tensor board is used for visualizing model training, including matrix modeling graphs. So in summary or in overall conclusion, I can say Tensor's core data structure in TensorFlow, Keras API, like high level API for easy model building and trainings, data API, like efficient data loading and pre-processing, model deployments, like you can saving the models, loading the models, serving the models. TensorFlow Hub is reusable to pre-train models. TensorFlow Lite is there. We can use to optimizations for mobile and edge devices. TensorBoard to visualizing the data model or the modeling training performances. So these all are the utilities and components collectively to make TensorFlow a very powerful and flexible framework for building and deploying machine learning models. If you have a specific questions about this utilities, definitely when we refer about the TensorFlow documentations, we can easily to get from the documentation as well. As already I told, just like sklearn, there is a tf.keras TensorFlow. If you can go ahead with the tf keras TensorFlow, you can go ahead and just take it. This is already you will get all the sequential and everything, so you will get it from this particular things, modules, activations, things is a classes, D-type policy, everything will be given class law space and all the class sequential functions. Each and every part is going to be given here about this particular things, activations. If you go ahead, overview of the activations. So you can see to it that ReLU is there. Lot of, I'm not talking about all the activation function. It's about sigmoid is there, softmax is there, swish is there, tanh is there. Lot of activation functions are there as well in the documentation. So you can refer the documentations for further understanding and a further study as well. Callbacks are there, backend applications, data sets is also given. A lot of data sets are given: Boston housing, California housing, CFAR 10, CFAR 100, fashion minutes, IMDb. We are going to see the CFAR 10 or CFAR 100 here. So DB is there. A lot of data set is going to be handled by the TensorFlow. So we can use it as a utility as well for this particular thing. So I'm going to apply the ANN dot add tf dot keras layer sigmoid. Layers dot sigmoid. So I'm using about that. Sorry, this is wrong. I did it. Same thing I got. Going to training my model. So training model. So compile the ANN dot compile optimizers. We use the loss function that is known as a binary cross entropy. Tricks is accuracy. We have to check your accuracies. Optimizers we are using. There are a lot of optimizers. The most important optimizers we called as the what I can say that Adam. Adam is one of the best optimizers I have found. Even the developers or the operationals are also find out this particular optimizer is the best. Otherwise, there are a lot of optimizers you can take from this documentations. There is a lot of optimizers are there. Initialize DT type policy and everything is given. So like we define the optimizers, Adam, optimizers work is what? Optimizer is an algorithms used to adjust the weight of the neural networks during the training to minimize the loss functions. Some optimizer is short for adaptive moment estimations. So very famous optimizers algorithms that combines the advantages of two other optimizers like Adagard, and the other one is uh, RMSOP, RMS prop, RMS props. It's a combination of both the things. Adam optimizers. Adaptive learning rates adjust the learning rate for each parameters based on the first and second moments of the gradients. Momentums incorporates momentums to help accelerate gradients vectors in the right directions. Is suitable for most of the neural networks and requires minimal tuning for hyperparameters. Then we use about the loss. The parameter is loss binary cross entropy. This loss function measures how well the model's predictions match the actual target variables. It guides the optimizers in updating the model's weights. The binary cross entropy use there's a binary classification problem like predicting whether the image contains or cat or not, like exited or not. Our data is there obviously. Then metrics is there. Metrics are used to evaluate the performance of the models during the training and testing. They are used to track how well the model is performing. So we can move ahead and perform our operations, complete it. Uh, we have to run this particular line of the codes. I'm just training the models and compiling the NN. So my model is going to go the training NN dot fit, NN dot fit, X train, Y train, batch size 32. Epochs I taken as the 100. Early stopping is also applied, but I'm not going to take it the early stopping. But mm, can I take the 100 or let's say I have to minimize, otherwise it will take a lot of times. 50. Batch size is totally up to you. I will come to that explanation as well till the time is model is going for to running. The more epochs is what actually let's we have to explain this so that everyone can get the understanding about this. Coding is not difficult. Please take a note. Coding is not difficult. Believe me, coding is not difficult. If your Python is good, coding is not difficult at any positions. So X-train, obviously your training data will go for the to train the models. It will take the very fast and you are getting the fast 250. About you can say, I'll come first to explain about this line of the code so that everyone can understand. So X-train, Y-train doing for the training the data model. Batch size we taken about this 32. So the number of samples proceed before the model internal parameters are updated. Batch size is, there will be the small batch size, large batch size. Or more updates per epochs, potentially leading to faster conversions, but higher memory usage when you use small batches. Large batch size, fewer updates per epochs, potentially leading to slower convergence, but reduced memory usage. Like we use very common default, we using 32, but it can be adjusted based on the data set size and available hardware or your systems. Epochs we are taking 50. Epochs is what? The number of times the entire training data set is passed through the neural network during training. That is, we can call it as the epochs. Epochs is fewer epochs. When we are taking a small epochs, the model might not learn enough and put underfit. More epochs, the model might learn more, but can also overfit if not properly regularized or validated. Just like we use 50 epoch is typical starting point. The optimal number of epochs may be determined through experimentations and validations. For example, your accuracy you are getting about this particular 0.86. You can just see to it that and try to see to it here about this particular at 0. How much you are getting 0 point and all this 0.8680 or something like that. 50 epochs is going to be taken. If suppose I'm going to increase about this, so loss function will be might be more going to be reduce or decrease it. So it might be happen, but we have to try it. Loss function is 3 2. So we can use 100, 200, multiple epochs about that particular thing as well. So just remember it about this particular stuff and try to understand it. This is your model is going to be trained. Now model is capable to give you the prediction as well. For example, if I will test with my data, like for example, if I will take text as a Y underscore prayed underscore probability is equal to n and predict x test. I can take as type. Let's first of all, because it's a binary, either zero or one concepts, right? From the X test, y parade props greater than 0.5 dot as type integer. That's totally fine if you can go ahead and perform it, but later I can perform it. But let's we have to run it. So it's going to be 63 by 63 is going to be done. So it's going to be now we can come to probabilities to binary. How we can go in probabilities binary as well. uh, we can take about and understand about this as well so that you will get a better understanding. Y parade, Y parade probab greater than 0.5 dot s type integer. That's totally fine. Then Y parade equal to, I'm going to Y parade dot dot reshape reshape, then Y parade, then Y test is equal to Y test dot reshape, then Y test one. That's fine. Result is equal to np dot concatenate. Concatenate is function is a combining of the y parameters x is equal to 1 and print. I can go ahead with the result. You can see to it that the result will be result. Print. Print. Hopefully it will work. You know, you can see that 0, 0, 0, 1, 0, 0, 0, 0. Because you taken the probability sometime if the value will become as the output value will be you were getting about the 0.5. So what it means, if the value we are getting as the less than 0.5 like 0.4 0.35 or something, so it will automatically consider as the zero. So because when the binary classifications would be there, the problems or the results or the output will become as a 0.5. So the what it means actually, it means actually about like you have to uh, we have to deal about like this one or zero because your prediction is exited or not. If you can go to your original data sets and see to it that here, sorry, your data set, so it's 1 0 about this. So if the outcome will be 0.5 or something, so hopefully you will get the results according to that particular stuff as well. For example, I can come to this explanation so that you will get the better understanding. For example, if I'm taking the data sets or print ANN, NN is your model name, predict SC dot transform. SC is your what? Scalar, right? If I'm not wrong, SC is a scalar. Otherwise, I will get an error that place. So and then again, the finding the error would be the difficult. So scalar transformation is we done in it or not? So scalar transformation, yeah, SC is a scalar transformation because the problem is that once, so this is your data, for example, assembly data. It's going to be taken as the, you can take two data here as well. Print. So both the things, let's we have to see to that were closed. You can see that false. Why? Because he said the condition is greater than 0.5. If it is a greater than 0. You will get a true. If it is a less than greater than 0.5, automatically you get a false. And when I'm not defining the probability of that, so I'm getting this 0.03. So what it means, my model will not understand about what 0.03. So that's why we use about this probabilities and all the things, so that this particular probabilities, so that whenever the result would be less than 0.5, it will automatically consider as a zero. Whenever the probability will be greater than 0.5, it will consider as the 1. So whenever there is a binary classification should be there, so you should always follow this particular score. Now we have to find out our all this, like the confusion matrix CF is equal to. These are the validations are very, very important. Confusion matrix, sorry, confusion matrix. Why this particular thing is come as the, then accuracy is there, right? Accuracy. One more thing was there. Classification report, I think. Classification report. Yeah. You can see that everything will, this is a confusion matrix. This is your accuracy. And this is obviously by default your classification reports as well. So this is all about your the model is sufficient to provide you. You can check with your any new data. This is the new data I'm taking here about, like this is 0.03. The same data is there. If you are going to change about the value or something, like, for example, if the value is something, why it's not going to click. For example, 800 or something here about, like I can record is like 80,000 10. If I will check it, still I'm getting the false. Sorry, I check it. So obviously it's depend upon the various factors whether you are getting about the output or not. 0.0116. So obviously it's still false. So we have to see to it that about already you know the correlations, which particular thing will increase, so which particular thing will decrease. So the correlation will be a very, very important part. So this is about the deep learnings, but I use about here the ANN. I can give the name as the ANN. Now the CNN I'm looking to here to sort it. So already I explained all the terms. Still anyone having anything not understandable, please let me know. But make sure that your Python, I believe me that coding is not a difficult task. Coding is a very easy part if your basic Python is clear. 100% each line of the codes is easiest way you can absorb, you can grab it and you can write it. Because the documentation is there. With the help of the documentation, you can perform lot of implementations, lot of work. So please take a note of that particular stuff. Now coming to uh, the next one is one more practical implementations. See, a lot of things we did it today, even a lot of k-means clustering and deep learnings, totally focus on hands-on. Please take a note. Don't believe on theoretical. The concept, you can understand it. But when you are performing the practical implementations, you will get the exact idea, exact knowledge, what or how the model is going to be trained, what is the neural, what is the layers, how many neurons we are using, 6, 8, and all the things. So this is again, I'm taking as the deep learning. AI is, or the deep learning I'm coming to here. Deep learning. This is also known as the computer visions, CNN. Is using for the computer vision purpose as well. It's the last part of this particular things is given. So deep learning CNN we are taking here. That's I'm coming to the again the example of the deep learnings. Fully connected neural networks, CNN, neural network architectures. Copy it. It might be an error. Guys, I will take a little bit time, so please allow me a little bit of time so I can take any different image as well. There are a lot of images out there. Yeah, I can take it. This copy. Curriculum is a big, it's my responsibility. I have to complete the curriculums. So that's why I'm taking. Otherwise, if the PPT would be there, that would be easy for me as well. Like I have to just show the PPT and explain it. But writing the codes and showing the uh, hands-on things, that is one of the important part. And believe me that hands-on things, the practical implementations, is very, very important. In future, when we are going to meet as well, I can show you about the deployment as well, how we can deploy it on the web app or the AWS services, Azure services. We can deploy this model as well. Like already I show you, I already explained how we can save the model, how we can load the models. There are different platforms, just like Flask, AWS, SegaMaker is there. A lot of platforms is there. Docker is there, where we can even Postman is there. We can deploy our models and check it. All this. Anyway, I'm coming to CNN. How the CNN is looks like. Obviously, the half part is the neural networks. I'm not saying that it's a half part is so I can write here about the CNN. 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 When you pass any image, whether it's a black and white image or whether it's a colored, it's a black and white image or whether it's a colored image, you are using or one channel or the three channels. Three channel, one channel means there means be black and white is considered as the one channel, and when we pass the image of the colored images, that's are called as the three channel. That's RGB, red, green, and blue. And the pixels range is from 0 to 255. Always remember it, that particular stuff. When this image is going to be passed, we have to apply the filter. That's convolutions. That's you might seen about this particular things. This is convolutions plus activation function by default required it. It's not like we are going to, because without activation functions, activation is not going to be performed. Your process is not going to be activated. So activation function will be a very, very important. ReLU we are using because it's saying that if the value is either it's going to be dealing with the 0 and 1. If the something is detected, it's considered as a 1. If it is not detected, directly that part will be treated as a 0. So that's why ReLU we are treating. There will be no confusions about like that. We can use the tan hyperbolics and other things, but that is something about the more mesmerizing things we have to do it manually. So the input kernel, then we have to use to pass about the convolution is what? Convolution is about the filters. Filters. There are different filters are available. 3 cross 3, 2 cross 2, 4 cross 4, 5 cross 4, 5 filters we have to apply. So we have to apply the filters. That filters will capture like the for eyes, it's required about the different kind of filters. For tails, we required a different filters. For leg, it's required a different kind of a filter. Filters we can also call as a kernel as well. So that's kernel. Suppose the filter is applied here. So the filter will capture this image, this area. Similarly, this area, this area, this area, this, and combination of all the things. And in the kernel is going to be treated one image that is coming here. When other filter or the kernel is applied here, that will become here. When other kernel or filter applied here, that come here. When other kernel or filter applied here, that will become here. Different. And a pooling is what? It's taking the maximum informations. It's pooling. Like it's going to be pool. Like this going to be pool and store at one place. Like whatever, when the image is passed from the filters would be like 3 cross 3. So all the 3 cross 3 will be not filled with the exact informations. At some places, the exact information is there. But pooling will take what? in filter or in kernel, whatever the maximum information is going to be placed, it's carrying that information. Then the rest is going to be kept out. So there will be no confusions. Like when we talk about like the tails of the cat, tails of the dog, tails of the uh, elephants, tails of the different animals. So once we understand the tails, if we see the back only the tails of that particular animals, we can say that yes, it's a cat image, it's a dog image. Why? Because that information is 100% carried out. So the filter is very important first step. Then the max pooling is taking the maximum information. There would be a multiple max pooling layers would be there. And once the max pooling is done, you can see that it's going to be flattened. Flattened means it's going to be vertically arranged. And once the vertically arranged, your fully connected neural networks will be comes and it's passing from the input layers, hidden layers, and at the end of that, you're getting the output layers as well. So this whole process is known as the feature extractions, feature maps. Again, the forward propagations backward, forward, backward, forward, backwards, continuously is happening. In convolutions, the extra thing is kernels or the filters. The second things we talk about this pooling. Pooling is what? To taking the maximum informations from your kernels or your convolutional layers. Once it's taking capable to grasp all the informations from the image, he is going to create the flatten layer, vertical layers. And that flatten is going to be connected with your fully connected neural networks or neural layer. So neural layers is already I explained is input layers, hidden layers, and the output layers. So it means here we perform the practical implementations about like this N and dens, about like the providing the layers about this input layers and all the things. Here we perform it, six and all. This all the neurons. But in this particular deep learnings, when I'm going to perform, I will also apply the kernels, filter size, image size would be there, then max pooling size. Max pooling we are taking 2x2, so it's we are considering 2D layers about the max. So 3D is also there, but in this curriculum says obviously we have to take the 2D about this particular thing. So anyway, we have to perform the practical implementations and let's see how we can go ahead and see to it that basically in CNN it's the image and the video is there. So the image is going to be captured by the kernel or the filters, and from the kernel filters, the maximum information is taken care by the max pooling layers. So max poolings is further going to be flattened. It's going to be flattened or the straight or vertical place, and from that, it's going to be transformed in the fully connected layers. And fully connected, already I explained it's input layer, hidden layers, and the outputs. So it's showing that whether it's a horse, zebra, or the dog. Anyway, let's see how to perform this practical implementation. So import numpy snp import pandas spd pcbon from tensorflow. Sorry, import tensorflow first. Import tensorflow, tensorflow as pf from tensorflow dot keras from tensorflow dot keras. Import data set layers models. TensorFlow dot class utils import to categoricals. Categoricals is from TensorFlow sequential dense from TensorFlow batch normalization. That's not required batch normalizations as well. You can write in a convolution max Plody, flatten is there, dropout is there, dense is finally define it. So we can define it as it is in the same line of the code. Why it's not going to be worked out? Sorry. Let's try to run it this line of a codes and try to work out it. So this see to that how many libraries we can use it. So I can go ahead connecting something that my interruptions is going to be happen. So connecting is done it from its RAM. You can see that 0.96 GB. Your import is due to missing package. Cannot import data set from Tensor Flow. Okay. Yes, models. Data sets. Okay. That's I miss the spell. Data sets. This will work. Yeah. Sometimes spelling mistake it happen. So I'm going to load the data set frame is frame labels test images test labels is equal to data sets dot cpar. You can go ahead and search it with the cpar 10, cpar 10, and cpar 10, cpar 10 and 100 data sets. So this is a cpar 10 data sets is there. You can use this cpar 10 data sets should be also there. So beer, dolphin, and everything should be there. Obviously, if you can go ahead and see to it that data sets is there, that's already I shown you about this. So this did Boston housing and everything is there 400. If you can go ahead and check it. Functions load the data. Everything is given. You can use from this particular way as well. Yep, about so just try to understand about this. In the documentation, everything is data CFAR 10. I'm taking CFAR 10 data. CFAR 10 load data. I can take it. Size is also important. I can go ahead and normalize my data here. The difficult practical implementation is normalize because we have to normalize pixel value to be between 0 and 1. So train images from test images is equal to train images. If, as I told, the pixel range is from that is that 0 to 255. So this is a very, very important step. I want to just show you about this. So downloading, as you can see that it's taking torrent freeze is going to be done. You have to perform it. That's how to till that time I can define is the class names. Done it with the class names. Let's I'm going to define one function here to see to it that function to plot images in grid. So defining functions plot images, images labels class names. Number of images also I can take its class name. Yes, sorry. Number of images, number of image 25 plt dot figure. I can take 10 plus 10 using for loop for I in range number of images. I can define its number of images for the PLT dot subplot phi comma phi plus 1 PLT dot xticks as it is xticks images create false. I'm show images I CM map PLT dot CM binary I0 PLT dot show. That's hopefully it will work. It's but I'm not getting output or what. Okay, let's see. So plot images, train images, train labels, train images, train labels. And hopefully it will I will get the output. So this is the images. Already I shown you the images as well. This is the image. You can go ahead and just check it with this image from your this website, CPAR10. That's aeroplane, automobiles, bird, cat, deer, fat dog, frog, everything is be there. CPAR10 versions, MATLAB binary version suitable for C programming, Python version is there. You can download it as well from this. And wait, but I'm not, I downloaded it directly in my file in the deep learning. So this is my data. You can just see to it that horse, deer, automobiles, all the things will be there. So I'm going to define my CNN model here. So define the CNN model. Model CNN, I just told about one thing. First of all, that's the convolution layer. Obviously, the image input shape is, we can take it, but we can go ahead and just check it. Models, sorry, model is equal to model. Obviously, the sequentialities, you can see to it that models, I can cut it, this particular things. Less time inflection. I have one more sessions at 3 p.m. So that's why I have to a little bit faster. 2:30 to 33, I have to take the break. And in the morning, I started the session as the 8:30 onwards. So the layers, you can see that layers. I did a mistake or what? Chill, that's totally fine. Layers, convolution. See to it that so that you will understand. Convolution 2D. You can see to it that. Try to understand it. It's 32. So I'm using 32 filters. You can see that I'm using 32 filters. And the filter size is 3 cross 3. Activation, I'm using ReLU. Input shape of the image is 32 cross 32. The image size of my 32 cross 32. And the 3 is having the 3 channel. 3 channel means red, green, and the blue. Please take a note of this and try to understand this line of a code. Layers dot convolutional 2D layers, just like as I told that convolutional layers I required it. This is a convolutional 2D layers I need it. And that is a 32 layers, 32 kernels I'm using or 32 filters. If you need it, you can go ahead and check it with the 64 here. For example, I'm using the 64. You can change it, 64 filters. The more filters, the better version of the output you will get it. Then layers of the max pooling 2D. Max pooling. This is 64 filters I'm using. I'm using the convolution ReLU here. The pooling is also going to be happen. So max pooling I'm also taking here. How many? That's 2 cross 2 max pooling is there. So max pooling. Max pooling is not like having the quantity. It's you have to just define the 2 cross 2 max pooling is you have to get it. So just see to it that max pooling 2D, this is done it. I'm using one more things. More layers I'm going to use it. So layers dot convolution. Now I'm taking 128 filters. In the first step, I using 64 filters, having the 3 cross 3. Now here I am taking the 128 filters of the 3x3 activation ReLU, again the max pooling. Till the time of whenever you are using about the max pooling and the other things, you have to use it the max poolings. Convolution is there, max pooling is there, because the maximum information we have to grab it. Please take a note of that particular things. We have to go ahead again. We have to use it here. One more I'm using, because a lot of less 256. You can see that 256 filters I'm using. 3x3, the maximum. If you do the uh, use minimum filter, low filters, your accuracy is going to be affected. Once this is done, so like this, all the three steps, the layers, convolution, 64, 128, 256. This is all about this particular convolution, convolution, convolution. Till whenever the convolution is there, pooling is there. Once the convolution, you have to stop using the filters. You can go ahead with the flatten. So I'm using the flatten here. So you can use about this particular thing. So we have to use it. Layers dot flatten. And just try to see to it this particular stuff, so that you will get the better understanding of this particular things. Flatten, I applied it. Now one by one I'm using. So first, as obviously I already explained earlier, first part I use 64 filters with convolution 2D, 128 filters with convolution 2D or max pooling 2D, then 256 filters with max poolings 2D. I utilize here continuous. Now here I'm using dense layers. This is dense layer. I'm using fully connected layer that performs a linear transformations on the inputs, and it is used for the classification or the regression task. Like we are using here 512 number of neurons in the layers. I using 512 neurons. Just try to understand it. And 10 is there. Softmax. So the first dense layers has 512 neurons with ReLU activation, and the second dense layers is having the 10 neurons with this softmax activation function. So just remember it, how we can use after the flatten means this particular part. Please take a note of this practical implementations. After the flatten, the picture will start for the fully connected neural networks. So obviously there is a 10 class, so I use about the output. This is, I can also consider uh the output, or the 10 class is there, so I can use it. This is the uh 10 class. 10 classes are there in CIFAR 10. In CIFAR 10. So that's why once I done it, let's see it will work or not. So incompleted, what incompleted? The bracket is incompleted. See to it that sometimes the bracket we will miss it. Now it's really treated fully. Now we have to check this summary, because your model summary, how your model looks like, because your model is very nice and very big model we created here. You can see that none. Total trainable parameters is 900764746. Trainable parameters, non-trainable. So that's very big model you created, very big parameters. Convolution 2D, you can see to it that the first, there is a 64, 100 and 1792 parameters. Then max pooling, we applied it. Max pooling, we did it. 64, 15, 15, 64. Then convolution when second layers we applied it 2D, 128 layers. Parameters. You can see that max pooling 66, 128. It's going to be breaking that particular, continuously breaking. Yes, see to it that 30, 30, 64. It's going to be crossing with the 15, 15 when apply max pooling. When it's a convolution 2D layers 13, 13, 128, it's going to have, you are using about max pooling, it's a 6, 6. So parameters will be completely reduced because max pooling 2D is not going to the parameters. So convolution 2D again 4, 4, 256. because we use about that. So it's coming as the 2 because it's max pooling is taking the maximum information. It's going to be reduced your convolution today, then flatten. How many 1024? Then dense we have to apply 512. Then there is a 10 zipper 10. So this is all about this. You can take any number of layers, any number of filters, any size of the filters. It's totally up to you. So just remember it. This is my models, trainable parameters. So just I'm moving towards the compiling the models. Compile, compile the model. So model dot file. Optimizer Adam. Loss is sparse categorical cross entropy. Matrix is accuracy. You can take anything. It's not about like this. Only I'm taking this particular step, so that's why you have to use it. So you can take anything. Okay. So just remember it when sorry why I created this one. The mouse is a little bit giving a problems. We have to run it. Matrix is cross entropy. It's done it. Now I'm looking to the train this particular thing. So history, CIFAR, history CIFAR. Giving the name as a history CIFAR. You can give any name. History CIFAR is equal to model.fit, train images, train labels, epochs 10. I'm taking only 10 epochs because data is very huge. Validation data, test images, test labels can perform this task. You can see that it's going to be started working in ports 10. So it's taking the time. So that's why I'm taking only 10 ports. You can see that 15, 16, 3, 1, 5, 6, 3 is going to be coming. It's already you now know that. So your model is going to start training. It will take a lot of times. So we have to wait at least 5 to 7 minutes. You can take a break, or if you have any questions in your minds, you can ask your question as well. I'm here to answer it, or I can at least give some of your queries answer. In that particular time of interval, we can utilize the task. Anyone having any questions? You can see that loss function, accuracy, everything is going to be. Anyone having any, but please do your Python better way. Definitely, you can do it. The transition is very easy from any domain to data science. You just need a good quality projects. You just need a good training partners, and definitely anyone can do the transfer. I was myself, I was not introduced because last week my throat was fully infected. Let's today I introduce myself. Myself is Dr. Masjiddin Khan. From last 1 decade, I can say that I'm into the training. Earlier, I started my career as an assistant professor in 2011 and 12. Later, 2016, I taught a lot of subjects in engineering colleges, like the machine learnings subjects. Subjects are there, data structures, lot of. So I have the knowledge. I did my PhD in the field of the data science, but my PhD is a statistics, but my project was in data science domains from IIT Bombay. And later on, I started learning about in 2016 onwards. I started learning in depth of the uh, data science. Fully started learning from the scratch. First, I uh, fixed my Python because who is Andrew Ng is my guide. I always prefer Andrew Ng. You can also refer it Andrew Ng. He's a really a great human beings to going for the deep learnings and all the things, you can refer these lectures, materials. I always follow his materials, lectures, always, whenever I will get a time. So Andrew NG is there. I refer him, apply a lot of study. In 1 year, I transitioned my careers. I started working as a Tiger Analytics in a Tiger Analytics as a data analyst first. So completed 1 year in Tiger Analytics, then to the math company. Both the companies are located in the Chennai. Uh, stay in Chennai for 1 years because Tiger Analytics provided me the work from homes. Works as a data analyst 1 years and then move on in the data scientist domains, handling their clients was the Pepsi. So seen that's which ad providing the most best revenue to their product and which particular advertisements we have to invest more money. So that kind of analyzations and the automated task we have to perform. It's the data is huge. Python play a very crucial role in my projects. Then I started delivering the training program as well because in my blood there is a teaching ability is there. Because from 2011 I started my career as assistant professor. So in the math company, I always start training the juniors whenever they come, freshers hiring is going on. I always started training to my teams, data analysts, data scientists, Tableau, Power BI, a lot of tools. Later on, I found myself like I can move into both the parts. So working in Chennai with separated from the family because my family is in Mumbai. I'm from back in born and brought up in Mumbai. So it's difficult to live alone in a Chennai. And as asked the math company, I worked there 2 years continuously. They're not allowing me to go ahead with the work from home. So I quit and I came to Mumbai and I started working with the Koenig Solution Private Limited. So Koenig Solution is the training service provider. You can search it. And I worked a lot of times and then I already enrolled the PhD doctorate in IIT Bombay. So work is really difficult for me to perform the job as well as perform the projects and the research and all the things. So I taken a break 6 to 8 months. Completed my task in 2023. I finished my PhD doctorate in the domain of the data science. Major is stats, but the project was in data science. Then I went and I joined with the Cloud Strats. The eShiksha is a venture who is providing the training to the IDMI. So from last 10 years, I am a certified data scientist from the Microsoft AWS. A lot of certifications I did in the domain of the cloud as well, like a solution architects I completed in the AWS, OCI certified, GCP certified, Power BI 300, PL 300, and all the certifications I did it. And from last 1 year, I started fully maximize my time in the training domain instead of operations. But still in cloud stats, I'm handling the operations 2 days, Monday and Tuesday. But rest of the day, I always provide the training services because our clients at the BHEL, GAIL India, IRCTC is there also there. Even the DRDO is there, our client. So we are providing the techniques because all the organizations are moving towards the data science and the data analysts of their AI and all the things. So they require the trainings to their departments. So this is all about my just small introductions in front of you. Because the epoch is running, only the two epoch is running. You can see that because it's a image data, it's not a text data or the structured data. So that's why it's take a time. So be patient with this particular steps. Definitely the model will be trained and it will reach the output as well. Anyone have to share any thing from your side, please go ahead. Till the time of the uh, epochs, you can share it, or you can just give the introductions of yourself. Those who are 13, 14 peoples are there, like Anuj, Akshay Pradeshi, Prasad, Purvati, Shwetari, but you are working, Smita Gupta, Aryan Malik, Rutuja, Harsh Bhatnagar. Please just, you can introduce yourself at least, because today is the last day. Can you hear me? Whether I'm audible or not?
Yes, hello, sir. This is Harsh Bhatnagar.
Yes, yes, Ash.
Am I audible?
Yeah, yeah, you're audible.
Yeah, thanks for the actually, first of all, this overall training program as well as an excellent introduction. It's good to know about your overall journey. So my intro is, yeah, I am working with a bank in Hyderabad. So my all 24 years of career gone into investment banking,
Okay.
and right now I am kind of running a team as well as a department in Hyderabad with a bank, multinational bank. Uh, so I was not sure. I have seen this is small, so because whatever I have seen, I have there are multiple places where I see even my company goes for training. People are continuously taking from different platforms this AI/ML training and all. I was just reading newspaper and suddenly found that this training is happening. To be very frank, seeing the kind of fees, I was not very sure, but I thought, okay, let me give it a try. What exactly is happening? This looks, how can a AI/ML course be happen in 5,000-6,000 rupees? Is it really possible or not? So I just tried my luck, and it was a
Okay.
beautiful journey. Thank you so much for that.
Yeah, thank you, Ash.
The good thing which I like about this overall program is it's not, as you mentioned, it's not PPT based. It's not like giving 30 slides, 40
Yeah,
slides,
yeah.
repeat it and go home. Right? So you have actually shared all the
I
notebook, all.
have slide with myself, so I will share my slides.
Okay.
Yeah, I will share my slides with you. You can read it by your end. But if I will just present the slide and from the slides I have to just explain it, what exactly you will see that. In slide you will see that how ebooks are running. In slide you will never see that's how this particular thing is going to be
Right.
happen. In slide you will never see this how the outcomes we can see to it. That
Yes, you're right. Yeah, this is what my quick intro. Thank you so much. I really appreciate that. Thank you.
Yeah, hi. This is Anuj Mehrotra. I'm working as a business analyst in Innodata. The company is in Noida. We basically work for the content for the Google and the publication houses across the globe,
okay.
as well as for the defense. So
Mhm.
my work is to implement the projects that comes into my organization and analyze those projects. Now, since we are moving towards the AI ML part, so I was looking for some certification course in it so that we can easily identify that what kind of work is coming to our organization and how better we can implement it and give results to the our client.
Okay. That's very nice. Anyone is there who want to say something more about this? This is already we done it. Once the model is trained, we can just pass one image and we can see to it that how it's going to be working.
Can we be in touch with you so that if we need any help,
Yes, yes,
we
you
can?
can always touch me. My number is there. You can touch with me. You can discuss with me.
Thank you.
So, sir, this is taking time due to the capacity of CPU, or there is a reason behind it?
No, no,
Like if
it's
I use
taking
GPUs and all.
it's a taking of the CPU obviously and the data set size as well. So that's all are the matters. Image data is there. Obviously, it's a huge data is there. So
Correct.
the
No, no.
training will
I
take.
just So my
image data generally takes time.
Yes,
correct.
yes,
So my
yes.
reason to ask this question is how exactly it has happened in real time environment when we are comparing lakhs of billions of billions or millions of images. Are we saying that we need better CPUs or GPUs?
Yeah, obviously,
Yeah.
we need better CPUs if you are performing on a billion of billions data. So obviously, we need a better PC or the GPU about that particular ones.
Okay. And is there any use case where we can use multiple PCs like blockchain kind of thing?
Yeah, virtual machines are there. See, the
Okay.
AWS or the other platforms are providing that multiple stuffs together. You can do it.
Got it. Thank you. Sir, do you have any course on Python as well? Starting from Python from
Yeah,
scratch?
I have. Uh, I will ping you. Just don't worry about that. I will ping you.
Okay.
Or everything you will get about that information through our colleagues. They will call you and they will tell you about what they can provide more about that. So I did
Okay.
a mistake, sir. At least I have to the 5 epochs. Otherwise, it will take a lot of times because it's taking a huge time. Obviously, it's take time. It's not about how the thing is done. It obviously when you are going to test with the data, obviously you will get the output as well. The model is trained. Obviously, you've seen that once the epoch is done, only the few steps is we have to pass the data and say the things only. Rest of the thing is totally fine. So the training is important. Once the model is trained, everything will be done.
Sir, do you see any, because you have a long, large experience in this area, do you see somebody who is not from maths background,
Mm.
but is still,
Yes, yes, sir.
it is
Yes,
possible?
sir. Current, yes, 100% is it's possible. Those who are not, what's background you have?
I come from pure commerce background, sir.
Yes, commerce background is also there. People are playing in my organization also under my team or in my
Mm-hmm.
team. There are people who done just a BCom and they're working for the risk analyst and the sports analyst as well. Both the
Okay.
places they are going to see there is a automated tools are there. We have to just learn that's how we can utilize the tools for the data
Okay.
like the ClickSense, the Tableau, the Power BI. There are different tools are there. With the help of the data, we can analyze the things. We can come to a certain decisions. We can see the create the models, KPIs, and all the things with the automated things. So obviously, a lot of people who are transit the career from the BCom to as a data analyst and as a data. See, obviously, when you are planning to transform career from in not from in the data science, your first step should be a data analyst, not directly go to the data scientist.
Yeah.
Because first, when you are capable, when you are in a positions to read, understand, and evaluate the data, definitely you will capable to go further step and just build the models or apply the models at the
Right.
positions. If you are not familiar with the data analyst post, if you are not familiar the role of the data analyst, you are not familiar how we can do the exploratory data analysis, lot of data visualizations, data analysis, then because EDA step is the taking the 40 to 50% time consuming. If the 100% workflow of the data science and from 40% to 50% is the time consuming step by the data analyst or the EDA, then you can understand it, what are the other step importance and how the EDA is important. So the
Right.
first step is always a data analyst. And obviously you learn the data science, but the first step, you should take the experience as a data analyst. And
Okay.
later on, you can move on to the data scientist. Otherwise, people are thinking like, I want to become a AI engineers, I want to become a ML engineer, deep learning engineers, or the Gen AI. They want to transit their careers from one domain to Gen AI. How the Gen AI is possible? If have you have the you have the command on the machine learnings, have you have the commands on the deep learnings. If the initial steps commands you not having, how can you become a Gen AI experts? Not possible. Because the initial step is you should deploy the ML models to the different domains or the platforms like Flask or this particular. We can talk about this. Docker is there. AWS is there. A lot of platforms are there where we can go and deploy our models, and we have to test it how it's working. So once you are comfortable to deploying the ML models, definitely you are comfortable to go ahead and deploy to DL models, and then you can go ahead with the LLM models. Because the initial step by step you can go ahead. If those because I found a lot of peoples are looking directly. I want to become a Gen AI engineers. How it's going to be possible? The Gen AI engineers, not at all, because your first step should be clear. If you are working from last 1 or 2 years in AI ML field, then definitely you can go ahead with the Gen AI. Okay.
Right. Yeah.
Yeah.
No, I think very well.
There are course for prompt engineering also available.
Yes, yes. Prompt engineering is also available.
And which tool do you feel better for data analysis? That's Tableau or the BI?
Hmm?
Which tool is better, Tableau or BI for data analysis?
Uh, Both are the same, but Tableau is little bit faster as compared to the Power BI. So I can suggest, like, if you are going to invest in learning about the tools, then Tableau is with better options. But if you, because we are using always the Microsoft. So Microsoft uh, provided the Power BI. So
Power
that's why
BI.
we are familiar with the Microsoft user interface and all the things. So that's why people feel that Power BI is quite easy as compared to the Tableau.
Apart from these two tools, is there any other tool that you suggest to look
What?
into? Apart from these two
Yeah,
tools,
Click Sense is also there. Click Sense.
ClickSense.
Yeah, Click Sense is there. Uh, then you can use the Python is also there. Python is by default is there. Then Excel is there. Excel is also the data analysis tools.
Yeah.
You can join with me. That's I can share my YouTube channel as well. You can refer it the YouTube channel as well. That's I'm providing the uh, some training things as well on YouTube as well. So you can refer it. It's a free of cost. You can refer it. That lot of things like Pythons and all the series I'm going to update very soon. So you can refer that as well for the learning point of view as a Python. But your Python should be strong if you are planning to transit a career from any other domain to the data science. Then Python should be strong. Why? Because this you can see that model implementations and all the things would be there. Yeah, I will share it on WhatsApp groups. Just because here, if I will share it, it will not show you. I will share you WhatsApp group, so don't worry.
Showing me you can't send messages because you are not a member of the channel.
No, no, I am a member of chat, but actually there is a restrictions. If we are going to paste YouTube channel or any other links, it will be not utilized here. You cannot see the YouTube link here when I will paste here because this is a
No, no,
Microsoft
no.
secret.
It's
Yes.
it's in my chat window. It's
Yeah, yeah,
showing
obviously.
me.
From your side, yeah, obviously it might be there. That's why even data set when I will share it, I have to share one WhatsApp group instead of here. Nowadays, Gen AI is the trend. Gen AI is amazing. Till that time, what I can do it, I can write the code. No, no, it's the last day of the class. Only 4 days, right? So that is the 4 days classes we have. Not next Saturday we have. That's why I taken the extra. Otherwise, actually the curriculum is big, but they are provided me this time span. Even I will talk to them. They will update you on the receive certification. If the digital copy is there, as well as the other copies are also there. They will update you by Monday. You will get the all the informations on WhatsApp groups. So don't worry about that. Certifications and all of this. Till that time, I can write it some line of a code here so that Gents are not taking it too much times because seventh is done it. I have the ready-made code here. Evaluate the label. Test accuracy variables. Test. You can go ahead with this. All right, for this. Predictions. Predictions. My predictions tf.keras sequential model or sequential test images. Without arguments, predicted models. That's totally fine. You can go ahead with this. So I created here about. That's I will show you the last one step. Get one directly here. So till the 8 one last 8 is going. It's taking a time. So keep patience. After that, two epochs more remaining. So once the two epochs will be done, let's we have to see that how it's going to be done. I did a mistake actually. The five epochs, should I take it? Then definitely it will work it. But it's taking too much time. So as I promised that I will finish all the things, whether it's a deep learning, whether it's computer visions, whatever the things should be there. So I will try to complete it. Whether it's a clusterings, whether it's ML, supervised, unsupervised, regressions, classifications, and I completed all the things. This is the last one thing is going to be remaining here. So let's see how we can do it, how I can perform it. time because even I have the 3:30 training, but it's 3 p.m. It's predicted cap GPG. I can copy it. Let's take it at the copy part. So, class. So ninth one is started. Val accuracy, they see to it that val accuracy 0.7348. This is the main accuracy is there. Validation accuracy.
So what is the difference between the accuracy over here and the val accuracy?
See, accuracy is something the accuracy of your training. Val accuracy is going to be because your data is going to be in this particular operations. Your sequence are train images, train labels, test images, and test labels, validation data. So the accuracy is when only accuracy is showing about the train images. And the validation accuracy will come from that's when the model is going to be trained the test part. So that's validation accuracy is your means when the model is going to be trained on the training data, it's going to be tested by the tested images. And that is known as the validation accuracy. Got it? Similarly, the loss is that is the training loss, and this is the val loss is known as the testing loss.
And what is this verbose equals to 2?
I will come to that, but yeah, this verbose is equal to 2. If you can see to it that like we are going to see our accuracy of that's like the test loss, test accuracy, model evaluate, test images, test labels. So that's we are going to see the evaluating method. Verbose is that's control the verbosity of the output during evaluation. Like 0 is no output, like silent mode, and 1 is looking for the display as a progress bars. And 2 is generally we are using displays one line per epochs, providing more detailed output, which includes the final evaluation matrix. So that's why we're using the verbose is equal to 2. And 0 is means no output, that's silent mode, and 1 is there are 3 categories, that's 0, 1, and 2. So we are always preferring the 2 so that we will getting the displays one line per epochs, providing more detailed output. Oh, that's so last one will be remaining is the 10th one. It's coming it's taking 130, 150 mils per second, milli per second steps is taking 266 seconds, 270 seconds, around 250 above is to finish it. Let's see how to. Yeah, I will share it. Just allow me 2 minutes. I can share it, sharing the notebooks. I think restricted, so anyone with those links, you can done. Let's copy the links, done it. That's 2 minutes. I can share it. This is the ANN. Similarly, I can go ahead with this particular restricted anyone with the links. Links, done it. Go with this. So both the links I did share it about in a WhatsApp group. Please refer it. Sorry, shared to somewhere else. So done it. Let's we have to try to with this particular things. Line of the code. So the test accuracy I'm getting, obviously this particular no need to this, that's 7200. It's going to be here. The predictions. So just see to it that. So I'm taking the 20th images here from this particular things. It could be horse or something, but where will comes that particular things? Actual and the predictions from the test data. So actual is a horse. Actual is also horse and the predicted is there. Now let's I'm check testing with the my any outside data sets. This is the data. This data is taken from this your testing data set. So this CFAR 10 images. Now I need to check with my any just like I uploaded one cat image from this image I uploaded it here. Now I'm going to check it here. Let's see how it's going to be happening or whether it's working or not. The load image is not defined. Why load image is not defined here? Just a second. Just a second. Load images were not defined. It is not defined. Tensor Flow, we have to image to array is also not defined. Okay, these are all the tensor flow utilizing. We have to utilize the tensor flow. Image to array is also need to define it. So there's all the libraries should be imported. But see, actually the predicted class is showing the dot. Means my model is not that kind of accuracy I'm raising here. We have to check any other image, horse. For example, horse. I'm taking the horse. Let's save images. This is a WebP file, so that will be the problems. We have to sort out the things. Save images. So that we can shape image. Or any size it's going to be considered. Save image. So images too. So we have to take it from this because 72% data is there, but we have to check it with the other image as well. So upload in this particular thing. So this is a horse image. So just copy path, the copy path, and just check it with this path. With this particular things. Now this horse is he predicted very well because the cat is only face is might be showing. So that's why he's not able to predict. You can check with the multiple images as well, upload it. Example, we have to use this image. Which image I'm taking? This one, right? So we can go ahead and check it. This was the image or what actually? Again, it's reading because my model is 10 because I taken only 10 epochs. 10 epochs is not proper. At least 100 epochs we have to take it. The more in depth it's going to be to perform it. We have to take more image of this, upload it. That's this too. Copy path. Oh, sorry. Same, I think I did it. I think this one, I don't know what exactly it's. Five. Well, the horse is trained properly. You can take any dog as well and just try it at your home as well. Try to do it at your side. So this is about the convolution. Your model is able to predict about the 72% is prediction is accuracy is we got it from this model, like 72%. You can see that test accuracy. So that means 28% chances are there some images is not going to be classified, some images is not going to be understand. So this is all about the practical implementations here. I've taken about like completed about hands-on tensor flow pairs, building NLP computer regions and all the things we created about this neural networks, hands-on tensor flow, and all the things I completed it here according to is from the overview AI about this to exploratory data analysis to ML to hands-on techniques. Will whatever the things is going to be decided. So I covered each and every topics according to the given by the IDA. So this is all about the workshops for 4 days workshops. Still, we are going to connect in futures. And this is Dr. Muhyiddin Khan's taking sign off from last 4 weeks, 4 days, 2 weeks. I already shared this notebooks. I will share you some materials as well, so you can refer it in future purpose as well. Till that time, take care.
Can you
Have a
can you share this module also? Because I don't have this module.
what
The module that you were showing, that
curriculum?
day wise module.
Yeah, yeah. I will share. I will share it on WhatsApp. Don't worry.
Yeah.
Okay. So take care. Have a nice day. Enjoy your weekends. Sorry for time I taken extra, but it's required to
Thank you very much.
complete to
And
the curriculums. Because the thing is like if I will not going to complete, I've thought like I'm not going to be a good and completing this curriculum. So that will be a very bad from my side as well, not the candidate point purpose as well. But thank you so much for your quite patience and listening the last 4 weeks. And thank you so much for understanding me. The last week I was feel very bad throat infection and all the things. Take care. Have a nice day. Enjoy your weekends. See you soon. Take care. Have a nice day.
thank you very much.
Thank you.